just that, today we are now going to do question 3 of 2011. So, we have a graph. What's the graph? Y equals to x cubed minus x. As per normal, here m is greater than or equal to 0 and a is less than or equal to -1. What does this mean? It means that we are now drawing a line tangential to the curve's local maximum. And coincidentally, it also crosses the curve at another point. Unless, when it's not tangential to the local maximum, which it might not be. So it might be tangential to the point of inflection, for instance, where it will only have 1. And sometimes it may have another line to the point of inflection, which can have 3. Yes, 3 points. Now anyway, this is a line which focuses on 2. Great. Use the fact that the line and cubic touch when x equals to b to show that m equals to 3b squared minus 1. As y equals to mx minus a and y is x cubed minus x such that x equals to b, then the gradients agree. So, we are now going to differentiate dy over dx equals to 3x squared minus 1. So, m equals to 3b squared minus 1. There. Simple. Strong order that a equals to 2b cubed over 3b squared minus 1. So as they also meet when x equals to b, the y coordinates on the graphs also agree. It rhymes. B squared minus b equals to m. b minus a equals to 3b squared minus 1 b minus a. So solving for a, we now have a equals to b squared minus b over 3b squared minus 1. It's actually b minus a. So a equals to b minus b squared minus b over 3b squared minus 1. Which, if we calculate this properly, we now have 2b cubed over 3b squared minus 1. There. Using the fact that this, which you need not prove, show that c equals to we are doing question part 3. So a is a large negative number, then y is mx minus a will be almost horizontal, meaning that the line will be tangential very close to the cubic's local maximum. Alternatively, one could argue that a is 2b squared over 3b squared minus 1 less than or equal to 0 only when 3b squared minus 1 is approximately equal to 0. So using the fact this, show that c equals to -2b. So if we expand x minus b squared x minus c equals to x squared minus 2bx plus b squared x minus c equals to x cubed minus 2bx squared plus b squared x minus cx squared plus 2bcx minus b squared c. So now if we compare the coefficients of x squared, if we do that, we will have 0 equals to 2 minus 2b minus c. So this means c equals to -2b. There. R is the finite region bounded by this line and bounded below by the cubic. For what value of a is R largest? So us, we're going to scroll down here and do some integration. We can see that as a increases, the tangent line and so the area of R increases. So this area is greatest when a is -1. In this case, b equals to a equals to -1 and c equals to 2. Hence, the largest area is 2x plus 1 minus x cubed minus x dx equals to 2 minus 1 3x plus 2 minus x cubed dx equals to 3x squared over 2 plus 2x minus x4 over 4 2 minus 1. And then if we go calculate this, equals to 6 plus 4 minus 4 minus 3 over 2 minus 2 minus a quarter equals to exactly 27 over 4. So we are actually done with this question, but I want to give you a note. Now do you realize that cubics come a lot in these MAT questions? So if your dad or your older brother has a copy of Bostock and Chandler, grab it and read the chapter on cubics. Actually, there are 2 parts of Bostock and Chandler. I'm actually talking about part 1 because it has a whole chapter on cubics. You realize I often reference it a lot in these videos because actually this book is actually very helpful when trying to solve questions which involve, well, cubics. Well, see you in another MAT video.